Hi everyone, welcome back to the Microsoft in 29 days self-paced course. So in case if you have not registered for the course, so you can find the course link in the description of this video. Once you register for the course and click on the start course button, so you'll be redirected to our site. And let us say that if I open day 9 or any day, so in that case what will happen, first of all I'll get the recordings of the two individual problems that we have done, and then you will get access to the all the 5 problems of that particular day. So you can see that I give 2 problems as the classwork that we do and 2 problems as the homework. Now let us discuss the problem, celebrity problem. So this problem is very interesting and it can be done using various ways. So we'll be discussing 2 or 3 ways for solving this particular problem. So the problem says that a celebrity is a person who is known to all but does not know anyone at all at a party. So there will be n people at a party and you have to find if there is a person who is a celebrity inside the party or not. So a person will be a celebrity if that person is known by all other people but that person does not know anyone in the party. In that case that person will be considered as celebrity. You can read this: a celebrity is a person who is known to all but does not know anyone at the party. So how will we understand by the relation? Like what relation will be given such that we can understand that who knows which person? So it will be given in terms of a square matrix of n cross n size, and the matrix name will be M, which will be used to represent the person at the party, such that if the element of the row I and j, so if basically matrix of ij, if M of ij is equal to 1, so this will mean that the person I knows the jth person, and same vice versa case will be for j. So if mat of ji, if M of ji is equal to 1, so that means j knows I. If M of ij is equal to 1, so that means that ith person knows the jth person. States that M of I will always be 0 because a person will not be knowing himself, right? So zero based index is followed here. So let us quickly copy this test case to understand what is the situation here. So let us see this test case first of all. So if we look at this test case, so we have 0, then we have 1, then we have 0, we have 0, we have 0, we have 0, okay, then we have 0, 1 and 1. So let me do the indexing part. So this is index 0, index 1, index 2, like in denoting person 0, person 1 and person 2. This was person 0, 1 and 2, okay. So if we see, so I can do one thing, the brute force way of doing it. Like I can see that this part, this index is given as 1, indicating that 0 comma, like it indicates, I can see that M of 0 and 1 is equal to 1. This indicates that 0 knows 1, okay. So I can say that 0 knows the person 1. And if I see this case, like I can see this I've written this wrong, like this would be 0, right? So if I see another case, so I can see that M of 2 1 is also equal to 1. So that means 2 knows 1, okay. So this means that how many people are there? Total people are like total 0 is there, 1 is there and 2 is there. 3 different people are there, and I can observe that 0 knows 1, okay, 0 knows 1 and 2 also knows 1. So what does that mean? If 0 knows 1 and 2 also knows 1, so this basically means that 1 is known by all. Now if you will see, right, so you can see that 1 does not know anyone. 1 does not know anyone because I can see in the matrix of 1, for 0, for 1 and for 2, like for 0 and 2, it does not know anyone. So that is why 1 is a celebrity here. So one of the very basic and the brute force way of doing it could be, what I could do is I could check for each and every row. So when I am at this, I can check for this 0th person. I can check its complete row, like each and every column. So if it is all 0, so this is not all 0. So which is all 0? I can see here, like 1 for 1, it's like it is completely 0, right? 1 does not know anyone. So 1 can be a potential celebrity. 1 can be a celebrity, okay? So I can do this, like I can do what I can basically iterate for each and every row, and for each and every person I can iterate like that will take order of n time for iterating for each and every person, and I can check for each and every person that if it does not, like if it is all empty, right, if that particular ith person does not know anyone, so in that case what I will do is, in that case I can say that this particular person can be a celebrity. So after this what will happen, I will check that that is this person known by all the n minus 1 other people. So if I will check for this one, is one known by n minus 1 people? Yes. So in that case I will simply return a true. But like as I mentioned, for one index, like for if I'm at one index, so for checking that whether all the indexes are 0 or not, it takes order of n time. So since there are n people at worst, so it will take order of n square time. So this is the brute force approach, and it is not that optimal. So can we do it in a better fashion? Yes, we can do it in a better manner. So what we can, instead of doing this, what we can do is we can simply insert all the elements into the stack. Like this will be order of n space approach, but order of n time approach. So what I can do is I can insert all the elements inside the stack. So I'll insert 0, then I'll insert 1, and then I'll insert 2. Then what I will do is, like whatever number of people I have, I'll insert them inside the stack. And then what we will do is we will simply take out 2 elements from the stack. So we'll simply take out 2 elements, we'll pop out 2 elements. So let's say I take out 2 and I take out 1. So like let's say I've taken this out, like let's say A is storing 2 and B is storing 1. So in that case what I will check is I will first of all check, does m of a b is equal to 1 or not? Does does a know b? If a knows b, so then what happens? If a knows b, then a cannot be a celebrity. So inside the stack I'll not push back a, I'll only push back b. So in that case I'll push back like b only. But suppose like if this happens, right, if this happens, then I'll say that inside the stack what you do is, inside the stack you push nothing but this value b, because if a knows b, then a cannot be a celebrity. Otherwise you have to think, otherwise if a does not know b, then b can if suppose that a does not know b, so in that case a can be a celebrity, because a, like if a does not know b, then b cannot be a celebrity, because b will not be known by all the people. So in that case a can be a celebrity because a does not know b. So in that case inside the stack what I would do is I'll push simply a. Okay, that is the concept here. So here if I'll observe, if I have taken out 2 and 1, so if I will observe, just 2 knows 1, right? So basically I can say that what, m of 2 1 is equal to actually 1. So that means 2 knows 1, so 2 cannot be a celebrity. So that's why I'll insert inside the stack, I'll insert this 1 only. Okay, and then I'll again see, is the stack size greater than 1? Yes. So it is having 2 elements. So I'll take these elements out, and I have 1 now and I have 0. So I'll check here. So I will check, like I will check m of 1 0. So m of 1 0 is 0. Okay, this indicates what, m of 1 0 is 0. So this basically indicates that 1 does not know 0. So if 1 does not know 0, so 0 cannot be the celebrity. 0 cannot be a candidate for celebrity, and 1 can be a candidate for celebrity. So I'll insert 1. Okay, then what will happen, I can see that when I come out of the stack, so only 1 is remaining, right? And only the potential candidate, only the candidate that can be a celebrity is remaining. So I'll take this out. Okay, I'll take it out of the stack, and I'll store it, let's say in an answer variable. Let's say I'll store it like 1. And then what I will do is I'll simply iterate. And what will I check? I will first of all, either you can check it like this, either you can iterate through the complete row of 1 and then check if all of them are zeros, if this count is n, and if the count of zeros in the row of a for person a, like if the count of zeros is n, and like if it does not know anyone, and it is known by n minus 1 people. Okay, so if the count of the number of people who know it is equal to n minus 1, then I'll return a 1. Then I can directly return this answer that that is the potential candidate. Otherwise what I will do is, otherwise I'll return a -1. But there is a better way of writing it. So what we can basically say is, we can write this using a for loop. We can say that for int I will start from 0 and I is lesser than n, and then I plus plus. And what you can basically observe here is that if it happens, first of all I have to say that I is not equal to answer. Okay, if I is not equal to the answer candidate, okay, then what I will check is, if like I need to check then when I can reject this. So I need to say that if I an answer, okay, if I an answer is equal to 0. Okay, so what does this mean? This means that if I does not know A, okay, or if I does not know A, then also then I'll simply return a -1. Or when can I return a -1? If the candidate that is that can be a celebrity, if the candidate that can be a celebrity, if it knows someone, then also it cannot be a celebrity. So in those cases I'll return a -1. Otherwise I simply return the answer. So let us implement this approach, and then we'll also look at the most optimal approach as well. So for doing this, what we will do is we'll simply declare a stack. Let's say stack int, I name it as st, and then I'll iterate through all the numbers starting from 0 till n, less than n, and I plus plus, and we'll insert all the elements into the stack. So stack dot push will simply push nothing but I. And then once we are done with this thing, so what we will say is that while the stack dot size is greater than 1, so if the stack size is greater than 1, so if it is having more than one element, then I'll take out the top element. So let's say I take out A is equal to st dot top. Okay, I'll take out the top element and then I'll pop it out. So I'll say st dot pop. Okay, then what I will do is I'll say that int B is equal to nothing but st dot top, now the new top that is there, and I'll pop this top out as well, out of the stack. Once I have popped these out, so what I will see is I'll say that if m of a b is equal to 1, so this means that if a knows b, so if a is knowing b, then a cannot be a celebrity. So in that case, inside the stack, what will I push? I'll simply push b, because b can be a celebrity. Otherwise, if a does not know b, then what happens? B cannot be a celebrity. So in that case, inside the stack, I'll push A, because A can be a celebrity, but since B is not known by A, so B cannot be a celebrity. Okay, that is what we will do. Now once we come out of this loop, so we will just have one element. So I'll say that int answer is equal to nothing but st dot top. So I'll take it out from the top. And then what we need to say is either you can count that for this answer, that either you can run two different loops, basically two independent order of n loops, and you can check that if this potential candidate, if this answer candidate that is coming out from the top of the stack, if the number of people that it does not know is equal to n, and the number of people which know this person is equal to n minus 1, in that case you can directly return this as the candidate, this as the celebrity. This will be celebrity, otherwise not. So but there's an optimal way using one loop only. So what I can do is I can run from I starts from 1, I is less than n, I plus plus. Now one thing that we can basically observe is, like, what we will think is, we will think that when will this not be a celebrity. So I can say that when answer I, like when m of answer I, so what does this mean? That when m of answer I suppose is equal to 1, so when the potential candidate for the celebrity knows the ith candidate, okay, in that case I will return a -1. Okay, if the potential candidate for the celebrity, if it knows someone, in that case I'll return a -1. Or if it happens that if answer candidate is not known by any ith person, so if it is equal to 0, in both the cases I will return a -1, indicating that this guy is not a celebrity, and I can return a -1. But there is one extra thing that I need to do. I need to check one more thing, that answer, like I should see this thing, that I can be equal to the answer as well. Okay, you can observe that I can be equal to the answer as well, and if I is equal to the answer, then this condition will get true. Like in this condition will get true, that m of I will become true, right? M of answer will be 0, so this condition will become true. So in that case I need to say that if I is not equal to the answer, okay, if I is not equal to the answer, so I need to check this thing, that if I is not equal to the answer, so if the potential candidate, if the answer candidate, if the celebrity candidate is knowing any ith person, or in that case it will not be a celebrity. Or if the ith person is not known by if the celebrity candidate is not known by any ith person, in that case I simply return a -1. Otherwise I'll simply return the answer. Let us try and compile this up. So it seems to work on the samples. Let us quickly submit this as well. So you can see that our solution was able to pass all the test cases. Now talking about the time complexity of this approach, so the time complexity will be order of n, and the space complexity would be order of n for this as well. But can we optimize the space complexity as well? Yes, we can optimize the space complexity as well. So we can make the space complexity like order of 1. So we can do it in order of n time, and order of 1 space. So what can we do for that? So for that what we can do is we can use some pointer approach, very standard basic approach. What we will say here is we will simply say that I will point my I to 0, okay, and I will point my j to n minus 1 to the last candidate, and then we will move based on the following approach. So what we will say is that while I is going to be lesser than j, okay, till then we'll keep on moving. So I will say that if m of j I suppose is equal to 1. So what does this mean? If suppose that the jth candidate, if the jth person knows the ith person, so in that case it cannot be a celebrity. So in that case I'll discard that person and I'll move to j minus minus. Okay, I'll move to one person lower. I'll move to the n minus 2th person, you can say, right? And in this way I'll keep on moving. Otherwise, if the jth person does not know, if the jth person does not know the ith person, so in that case ith person will not be a candidate for the celebrity. So in that case I'll do an I plus plus. Okay, I'll move to the next I. So that is what we will try to do, and then then our answer candidate will be nothing but I. Okay, so let us quickly change this code a bit and see what we have to do. Like instead of writing this stack part, what we just have to do is we just have to do this thing. What we will be doing is, like, I'll say that int I starts from 0 and j starts from nothing but n minus 1, and then what we would do is we will say that while I is lesser than j, while they do not cross each other, while they do not come across each other, till then what I'll say is if it happens that m of I, let's say m of ji is equal to 1. So if j knows I, then j cannot be a celebrity. So I'll move to the next person, that is j minus minus, because j is pointing from the end. I'll give another person a chance. Maybe that person can be. Okay. Otherwise, if the j does not know I, so if j does not know I, so in that case I cannot be a celebrity, because if I is not known by someone, so how can I be a celebrity? Because I should, if I was a potential candidate for celebrity, then I should have been known by all the people. In that case, what I'll do is I'll simply say that, okay, answer is equal to I. So I'll store this ith candidate as the potential candidate, and then as the celebrity candidate, that it can be my celebrity candidate. And again I'll iterate. So if I is not equal to the answer, same case. So if it happens that the candidate for the celebrity, if it knows any ith person, so if m of answer of I is equal to 1, so if the candidate that can be a celebrity knows someone, or if the candidate that can be a celebrity is not known by any ith person, so if it is 0, then I'll return a -1. Otherwise I'll return the answer. So let me compile this code as well. Okay, so it works on the samples. Let us try and submit this as well. So you can see that this solution was also able to pass all the test cases, but in this solution the space complexity is order of 1, time taken is order of n, whereas in the stack solution it was order of n, time taken and order of n space. So you can see how we optimized from order of n square to order of n, and how we optimized from order of n space in using the stack to order of 1 space. So I hope that you enjoyed this video. Thank you. In this video we will discuss the problem get minimum element from the stack in order of 1 time. So the problem says that we'll be given n elements and our task is to implement a stack in such a way that we can get the minimum element of the stack in order of 1 time and order of 1 space. So let us discuss about this. So let us say that our stack is containing some elements. Let's say our stack is containing like 7, 9, suppose it is containing 6, then let's say it is containing 8, then let us say that it is containing something like 2, okay, and 3 as well. So first of all, suppose that if it is containing an element, like if it is containing 3 here, so up till now what is the minimum element? So the minimum is 2, so I need to give it in order of 1 time. And suppose that I have to pop the top element out, so now still the minimum element is 2. Suppose I pop this 2 out, then the minimum element is nothing but 6, and I need to give it efficiently. If I pop 8 out, then still the minimum element is 6. If I pop 6 out, then the minimum element is 7, and I need to do this without iterating through the stack. And if I remove 9, then the minimum element is 7. So that is what the concept in this problem is. Now let us say that if we have been given a particular set of elements, suppose that we have been given these commands, like we have to push Like suppose we are given some certain commands for pushing. Suppose we are asked to push 6, then we are asked to push 15, then let's say we are asked to push 4, then we are asked to push 2, and then suppose that we are asked to push 5. So one by one, if we are asked to push, so what we can do? So for this, there's a concept that you can apply. So I am telling you that concept here. So in this part, basically what we'll say is, suppose this is a stack, because it will be represented suppose in terms of arrays. So what we will be doing here is, suppose that inside the stack I insert 6. So if the stack was empty, in that case I'll say that okay, the minimum element now is 6. Then I insert another element. So suppose I insert 15. So since 15 is a greater element, okay, since 15 is a greater element, so I will not bother. Since 15 is greater than my minimum element, so no worries, I'll directly insert it. Then I insert 4. The moment, like, then I want to insert 4. The moment I want to insert 4, so in that case what I will do is, instead of inserting 4, I will insert what? I will insert 2 into the element, that is 4, minus the minimum element. Okay, that is what I would insert. So in this case, when I say this, so 2 into 4 is what? 8. 8 minus 6 is nothing but 2. So instead of inserting 4, I am inserting 2 in its place. Okay, because according to this formula, that is 2, this will be nothing but 2 into the element that I want to insert minus the minimum element. And apart from this, I'll update my minimum element, and the minimum element will actually be this element. So that will be nothing but 4. Okay, then what will happen? I'll come to another element. So when I come to this 2, so I can see that this is minimum, right? This is like, this is lesser than 4. So I'll say that I'll insert what? 2 into 2 minus 4. So in place of this element 2, I'll insert a 0 here, and I'll update my minimum to nothing but 2, because 2 is actually the minimum element. Then what we will do is, when I come to this element 5, okay, when I want to insert this element 5, so since 5 is greater, so I'll directly insert it without any issue. Now what happens when someone will ask me that, okay, tell me till this point what is the minimum element? So like, if all these elements are inserted inside the stack, suppose it will be inserted like 16, 5, 4, 2 and 5. So if they are inserted, so which is the minimum element? So minimum tells me that okay, the minimum element is 2, fine. Then suppose if I even pop out 5. So even if I pop out 5, still the minimum element is what? Still the minimum element is nothing but 2. Okay, then if I see 2, so suppose if I am popping this element out, okay, so what does this mean? Basically I can see that the top element is 0. So if I am popping 0 out, then what will happen? If I am popping this element 0 out, so I need to update. What should I update? I should update my minimum element. So I'll pop this guy out, but how will I update? So I'll say that minimum element is equal to nothing but 2 into the current element minus the like it. I will say that it would be nothing but 2 into minimum element. So minimum is equal to 2 into minimum element is currently 2, and minus the top element. So the top element is 0. So in that case what I'll get is, I'll get back 4. Okay, I'll get back 4. So inside my minimum 4 will be stored. Okay, because if I am removing 2, then this element is getting removed, and actually 4 is the minimum till here. Okay, so that is how I'm getting it. Now what will happen is, now my minimum gets updated to 4. After that, when I'm at this element, okay, so currently the element that I want to pop out, suppose I'm following a series of popping operations after the push operations. So after this I have 2. So if I have 2, so what can I do with 2? Like 2 is lesser than the minimum element. In that case again I'll pop out. So I'll say that now the minimum will get updated to nothing but 2 into the minimum element, that will be nothing but 8. 8 minus the current top, so that will be 2. So I'll be restoring 6. So minimum will get updated to 6. Okay, because if I remove this element from the stack, then the minimum element is 6. If I remove the previous minimum element, then the minimum element now is 6, nothing but 6. Okay, then if there is an element that is greater than like this element is greater than the minimum, so I can directly pop it out because there will be no issues. Then what happens, I have this element at 6. So after this, let's suppose I have to pop out 6 as well. So in that case what will happen, whatever I mean by minimum is storing, I don't care. If the stack is empty, so we'll simply return a -1. So that is what we will try to do, that while we are applying the push operations, so if we get a particular element that is lesser than the minimum element, right, if we get a particular current element that is lesser than the minimum element. Okay, so in that case what we will do is we will store it in a new format inside the stack. So we will say that we will do stack dot push nothing but 2 into the current element minus the minimum element, and we'll update our minimum element to that element. Okay, we'll update our minimum element to that particular current element. Okay, that is what we will do. And while popping out, okay, while doing the pop operations, what we can observe is, while we are doing the pop operations, so if the current top element is lesser than the minimum element, in that case what we will do is we will simply say that, let's say we will have a temp. Inside the temp we'll store the minimum element, like minimum element. Okay, inside the k we'll store the minimum element of the array. Okay, we'll store the minimum, and then we need to update our minimum. So in that case the minimum would be nothing but 2 into the minimum element minus the top element of the stack. Okay, so that is what we will try to implement. Let us try and write the code for this. So suppose we have been given these functions, so we have to write the code for them. So if we have to implement this function, let's say get minimum element. So if we have to consider for the cases. So if suppose that the stack dot empty, if the stack is empty, right, if the stack dot empty, if I call for stack dot empty and it returns me a true if the stack is empty, in that case we will simply do what, we will be simply returning a -1 because the stack is empty. Okay, otherwise what we'll return is, we'll simply return the min element. Okay, that is what we will do here. And apart from this, there is a pop operation and there is a push operation. So let us quickly write the push operation first of all. So inside the push operation what we would be doing is, we will say that if the stack is empty, right, if stack dot empty, if the stack is actually empty, right, so in that case what we can basically say here is, we can say that if the stack was empty earlier and we are inserting an element, so I'll say that minimum element is equal to nothing but x, that element that I inserted, and then I'll push it into the stack, pushing the x element into the stack, and then we will simply return from the recursive call. Okay, if it happens that the current element that I'm inserting, if it is lesser than the minimum, okay, so in that case what are the things that we will be required to do? So in that case inside the stack we will simply push 2 into the current element x minus the minimum element. Okay, and then what we will do here is, we will say that minimum, like I will write it like this, minimum element, and here also minimum element. Okay, and then we'll update our minimum element is equal to nothing but x, because this is lesser. Okay, now else if this element is not lesser, so we will say that we can directly push it inside our stack without doing any other thing. Now let us talk about the pop operation. So we will say that if the stack dot empty, if the stack is empty, then in that case we will not be able to pop out and we'll simply return a -1. Otherwise what will be the circumstances? So otherwise, first of all we'll take the top. So let's say I take the top element of the stack as st dot what is the name, like s dot top. Okay, so first of all I'll take out the top element of the stack. Once I've taken out the top element of the stack, so I'll be basically popping it out. Okay, because I had to do the pop operations. But now what are the circumstances that I will do? So if the current top element is lesser, like is lesser than the minimum element, so that means my minimum element needs to get updated. And in that case what we will say is, like we will say that int, let's say temp is equal to nothing but, inside the temp first of all we'll store the minimum element, because that is the element, like if t is lesser than the minimum element, if the current top element is lesser than the minimum element, in that case we want to return this updated element, because we had changed it while pushing it, we had changed it to 2 into minimum element, 2 into x minus the minimum element. So we need to change it. So what are the circumstances here? First of all we'll store it inside the temp, because basically this is a minimum element, so we want to return it. Okay, so we want to return this particular temp, but before returning it we need to update our minimum element as well. So we'll say that minimum element is equal to nothing but 2 into the minimum element and then minus the top element. Okay, minus the top element. That is what we would do. And then in the else part we can simply say that we can return the top element without any issues. So let us try and compile the code for this particular approach and see what we get. It seems to work on the samples. Let us try and submit this code. So our solution got accepted. Now in this approach, we are getting the minimum element in order of minimum element of the stack at any point of time in order of one space and order of one time. Thank you.